Alright, good day everyone. So welcome back to my YouTube channel, and this is Kasaligan Vlogs. Today we will be talking about addition and multiplication rule of probability, and this is mathematics in the modern world. So let us define addition rule of probability. So there are two rules in addition of probability. So the first rule is Rule 1, probability of mutually exclusive events. Two or more events are mutually exclusive if the occurrence of one of them excludes the probability of the others to happen in the same trial. It refers to as the sum of their separate probabilities. So therefore we have here probability of A union B is equal to probability of A plus probability of B. So this one could be stated as or union. So that is mutually exclusive. So there is a separate probabilities. The second rule is not mutually exclusive events occur together, meaning there is a common. So this is probability of A or B is equal to the probability of A plus the probability of B minus the common of this, which is the probability of A and B. What is the common of A and A or B? So that is rule number 2. Again, there are two rules: probability of mutually exclusive events and not mutually exclusive events. So here is an example. Determine which events are mutually exclusive and which are not when a single die is rolled. So first is getting an odd number and getting an even number. So let's have letter A. So if this is mutually exclusive event, so this is odd number. So we could say that this is a mutually exclusive event. Mutually. So meaning to say mutually, meaning to say separated probabilities, because the odd numbers are 1, 3, and 5, and the getting the even number is 2, 4, and 6. So in this first event, this and second event has no common of the two. So this is mutually exclusive event. No common. Okay, next is getting a 3 and getting an odd number. So letter B, getting a 3. So therefore this is getting a 3 and getting an odd number 1, 3, and 5. So we could say that this is number 2 is not mutually exclusive event. This is mutually. And number 2 is not mutually because there is a common 3 and getting an odd number, because 3 is an odd number, so therefore this is not mutually exclusive events because event occur together. Letter B, letter C, an odd number and a number less than 4. So this is not mutually because an odd number 1, 3, 5 and less than 4, which is 1, 2, and 3. So therefore 1 and 3 are the common of odd number and number less than 4. So therefore we could say that these events are not mutually exclusive because events occur together. Letter D, getting a number greater than 4 and getting a number less than 4. So we have here get greater than 4. We have 5 and 6, and less than 4, which is 1, 2, and 3. So therefore, we could say that this is mutually exclusive event because event does not occur or there is separate probabilities. Okay. Next, we have here example number 2. Determine which events are mutually exclusive and which are not in a single card is drawn from a deck. For example, we have here getting a jack and getting a 7 and getting a jack. So therefore this is mutually because jack and 7 are separate probabilities. There is no common. Letter B, getting a club and getting a king. So in letter B, we have here club is from ace to king. But getting a king, so there is a common here, from ace to king and king, so therefore the common is the king of club. Okay, the king. So this one, the king of clubs. Okay, the king of clubs is the common between this part. So therefore this is not mutually, because in the club it includes the king of club. Okay. Letter C, getting a face card and getting an ace. So this is mutually exclusive, because a face card, there's no an ace of a face card. So therefore face card is jack, queen, king, and an ace is separate probabilities to the faces card. Okay, letter D, getting a card and getting a face card and getting a spade. This is not mutually exclusive event, because when you get a face card, so we have here jack, queen, and king, so we could also get the spade here. From the spade is from ace to king, so it includes jack, queen, and king. So there are spade here in a face card, which is jack, queen, and king. So again, the face card, this face card includes the spade, which is jack, queen, and king. So therefore, this is not mutually exclusive event. Okay, so let's proceed with example number 3. A box contains 3 glazed donuts, and we have here 4 jelly donuts and 5 chocolate donuts. If a person selects a donut at random, find the probability that it is either a glazed donut or a chocolate donut. So first thing that we're going to do is to get for the sample spaces. The sample space here, okay, so there are 3 glazed donuts and 4 jelly donuts and 5 chocolate donuts. If we're going to add this one, the sample space is 12. So the question here is find the probability that it's either a glaze or a chocolate donut. So we are going to find the probability of glaze or chocolate donut. What is the probability when we have a glaze? So glaze is 3, so therefore 3 over 12, because of sample space. Plus, we have to find or. The word or means you are going to add the probabilities, or that is add, and that is multiply. So glazed donut or a chocolate donut. So chocolate is 5 over 12. So therefore we have 8 over 12, that is equal to 2/3. So again, we have to simplify when I talk about probabilities. Okay, so that's example number 3. So we have here example number 4. At a political rally, there are 20 Republicans, 13 Democrats, and 6 independents. If a person is selected at random, find the probability that he or she is either Democrat or independent. So we are going to talk about Democrat or independent. Okay, so there are 20 Republicans, 13 Democrats, and 6 independents. They have a total of 39 here, part of the political rally. Okay, so we have here 20 Republicans, 13 Democrats, and 6 independents. The question here is we're going to find for the probability of Democrat or independent. So first, the probability of Democrat is 13 over 39. Plus the probability that we're going to get independent is 6 over 39. So therefore we have here 19 over 39 is the answer for the probability of either Democrat or independent. Next question, we have the example number 5. A single card is drawn at random from an ordinary deck of cards. Find the probability that is either an ace or a black card. So let us have first, how many aces do we have? So 4 ace. Okay, 4 aces and 26 black cards. Okay, we have here 13 clubs and 13 spades. Okay. In the black cards, 26 black cards, there are 13 clubs and 13 spades. So in these 26 blocks, it includes 2 aces, which is 1 club and 1 spade. So therefore, there are 2 common here. So therefore, this is not mutually exclusive. So there are 2 common here, which is 2 of 2 aces of black cards. Okay. So the 2 aces, which is the common here for 4 aces, which is a black cards, which is 1 club and 1 spade. So therefore, the probability of ace or black card is we're going to get 4 over 52, because that is the number of total of deck of cards standard, plus the 26 black cards over 52 minus the common, which is 2 over 52. So therefore, which is 28 over 52, or shall we say we have 7 over 13. Okay, 7 over 13. Again, this is not mutually exclusive because the 4 aces could have 26 black cards, which is 2 aces of the black cards here. That is a common between 4 aces and 26 black cards, which is the 2, and we have to deduct the probability, that is P and P. Okay, that's 28 over 52, that is 7 over 13. So example number 6. In example number 6, we're going to find the probability of getting queen or diamond in a deck of cards. So in the queen, there are 4 queens and diamond, which is 13. For diamonds, which is 13. Okay, so in queen, there are 4 suits and it includes diamond. So therefore, the common between here is the queen, queen suit, which is diamond. So the common here is 1, which is the suit of diamond. So therefore, the probability of queen or diamond is equal to 4 over 52 plus 13 over 52 minus 1 over 52, which is the common between 4 queens and 13 diamonds. So therefore, we could have the answer is 16 over 52. And that's the final answer for this example number 6. Okay, so let's try this at home. 5 cards are dealt from a well-shuffled deck. Find the probability that all are face cards. Find the probability that 3 are face cards and 2 are eights. And find the probability that all face cards are all red cards. And find the probability that none is a face card. For number 2, if 1 card is drawn from ordinary deck of cards, find the probability of getting the following: a king or a queen or a jack, and a club or a heart or a spade. So comment your answers here below their YouTube channel comment box. Thank you. So let's proceed with the next topic, which is multiplication rule of probability. So multiplication rules can be used to find the probability of 2 or more events that occur in sequence. So multiplication rule number one, two events A and B are independent events if the fact that occurs does not affect the probability of B occurring. So probability of A and B is equal to the multiplications of its probability, which is probability of A times the probability of B. Another way we could say that this multiplication rule number one is with replacement. Okay, with replacement or being returned. Okay, in case number one. In case number two, multiplication rule number two, when the outcome of the occurrence of the first event affects the outcome or the occurrence of the second event in such a way that the probability is changed, the events are said to be dependent events. So we could say that this is without replacement or that being returned. So therefore, probability of A and B is equal to the product of probability of A times the probability of B such that A had happened. So it has been already, we know already the probability of A, then without replacement, so the probability of B would be affected here because without replacement, when you get the probability of A and not being replaced, so therefore the probability of B such that A had happened already will be affected in this probability of B. So again, there are two rules. Multiplication rule number one, it could be with replacement, and the second one is without replacement. As long as in multiplication rule number one, it does not affect the probability of B occurring, and multiplication rule number two, it affects the outcome or occurrence of the second event in such a way that the probability is changed because it has not been replaced or being returned. Okay, so let's have example number one. A coin is flipped and a die is rolled. Find the probability of getting a head on a coin and 4 on a die. So probability of head is equal to 1 over head is 2. And probability of 4 in a roll of a die is 1 over 6. So therefore, there is a separate probabilities. It does not affect the occurrence of the second event. So probability of A and probability of head and probability of 4 is equal to 4 and a half times 1 over 6. That is 1 over 12. So this is the probability when you flip a coin and the door right die is rolled of getting head on a coin and 4 on a die. Example number 2. A card is drawn from a deck and replaced. So take note of the word replace. So we could say that is rule number 1 or multiplication rule number 1. Then a second card is drawn. Find the probability of getting a queen, then an ace. So first is we're going to get the probability of queen. So the probability of queen is equal to 4 over 52. Since it being replaced, so the second probability, which is the probability of ace, will not be affected, which is 4 over 52. So therefore, probability of ace, queen, and ace is equal to 4 over 52 times it is being replaced. So therefore, we could not 4 the event and the sample space will not be affected. So therefore, 4 over 52 still. So therefore, we have 16 over 2704. And we have to simplify this one. Based on the calculator, we have 1 over 169. So there is the probability of getting queen and then an ace. That is example number 2. Example number 3. 3 cards are drawn from ordinary deck and not replaced. So take note of the word not replaced. So find the probability of these events. First is probability of jacks. So since this is not being replaced here or not returned, so the first probability, since we are going to get 3 jacks here, so the probability of getting jacks is 4 over 52, and this is the first jack, times the probability of the second jack, since it's not being replaced here, so still it would be affected because it is not being replaced. The 4 jack will become 3, and the sample space will be subtracted also because you did not replace one of the jacks. The third is, since we need to get 3 jacks here, so that when we did not replace the second jack, so therefore it will be affected too, and the sample spaces also will be affected. So therefore these are the 3 probabilities when we get 3 jacks. Okay, so we have here 4 over 52 times 3 over 51 times 2 over 50, that is 24 over 132 times 600. If we're going to simplify this one, 1 over 5,525. So this is the probability of getting 3 jacks in this part. The next part is we have going to get an ace, a king, or a queen in order. So we have here probability of ace, king, and queen in order. Since it is not being replaced here, so we could have 4 over 52 for the first row for ace. It is not being replaced. Does it does it affect the king, the event king? No, it does not affect the king. But you did not replace ace in the second row. In the second row, the sample spaces will be affected here. Why? Let's have again. First is 4 over 52, and we did not replace 4, so therefore still the event of king is 4, but we did not replace the ace here, so therefore it will be affected the sample spaces. The next is we need to get for the queen. Since the queen is the event would not be affected by the king, so therefore still this is 4 and did not replace or return, so therefore it will be affected by the sample space. So therefore 4 times 52 times 4 over 51 times 4 over 50, the result is 64 over 132 600, or we have here 8 over 16,575. Again, in ace, 4 over 52, since it did not replace here, so the king will not be affected, but the sample spaces, since we did not return one of the ace here, so we have here 4 over 51, and we did not return one of the king here, so the sample space will be affected, but not the event queen will be affected. So it does not affect the queen here when we draw king, since these are separate face cards. Okay, so that's example. This is number 2, getting an ace, king, and queen in order. Next is club, spade, and a heart in order. This is number 2, and number 3, probability of getting club, spade, and a heart. So we have here the club is, there are 13 clubs from ace to king, so therefore 13 over 52 times, since we did not replace the one of the clubs here, so therefore 13, it would not affect the spade. The event of spade will not be affected, but the sample space will be affected since we did not return the club. So therefore this is 51 times, the heart is 13 still, over, we did not return the spade, so this is 50. So therefore we have here 2,197 over 132 600 is equal to 169 over 10,200. So this is the answer. Again, so the club here, there are 13 clubs from ace to king over 52. Okay, for this is the club. Since we did not replace the club, or we did not return the club here, by drawing the spade, the event will not be affected because this is a club, but the sample space will be affected because you did not return one of the clubs here. So we have here 51, but this event will not be affected because the first draw is a club, but the sample space only will be affected. By drawing the heart, it will not be affected by the spade because spade and heart are the same quantity or the same suits here. So we have here 13 over. Since we did not replace the spade, so we have here 50 over 50. So only the sample spaces will be affected. So therefore, if we're going to multiply, there's 169 over 10,200. Next is getting 3 clubs. Okay, in number 4, we have to get 3 clubs. Getting 3 clubs. Since we're going to get 3 clubs, there are 13 clubs here, which is 52. And we did not replace the second card. So club 1. So since this club, we did not replace it, so the next club that we're going to get is 12 over 51 because the event will be affected because the previous card is a club and the sample space also will be affected because we did not return the club. Times, since we did not return by the second draw, the third draw will be affected. It will become 11 over 50. So therefore, if we're going to multiply this one, 1,716 over 132,600, or simplify, which is 11 over 850. This is 11 over 850. Okay, that is example number 3. Let's proceed with example number 4. In example number 4, so we have here box 1 contains 2 red balls and 1 blue ball. So let's have box 2 contains 3 blue balls and 1 red ball. A coin is tossed. If it falls heads up, box 1 is selected and the ball is thrown. If it falls tails up, box 2 is selected and the ball is thrown. Find the probability of selecting a red ball. First is we're going to get the probability. If this is the coin, if this is the coin, so if this is the coin, there is a chance or the probability that you have the probability of box 1 is 1/2 since this is a coin. And the probability of box 2 is 1/2. Okay, again, so the probability of box 1 is 1/2 and the probability of box 2 is 1/2 because a coin is tossed here and if falls heads up, box 1 is selected. So therefore, the chance of selecting box 1 is 1/2 and the chance of selecting box 2 is 1/2. So if this is box 1, since we have here for box 1, we have 2 reds and 1 blue. For box 2, 3 blue and 1 red. So since in this case, if we select box 1 here, the probability that you will get red is in case that we able to draw red here, the probability is 2 over 3. Okay, 2 over 3 because the total here is 3 and the total is here is 4. And if we're going to get if the one that we're being selected here in the ball is drawn, if there is probability of blue, here is 1 over 3. Okay. If in case that we choose box 2 here, so we have here ang box 2. So what is the probability when we get red in the box 2? And the box 2 we have here 1 over 4. And for the probability of blue, so we have here 3 over 4. So we have to get the outcomes here. So probability of box when 1 multiply here for the red is equal to 1/2 times 2/3. That is equal to 2/6. And if we choose box 1, but we have drawn the blue, which is 1/3. So for the blue, so 1/2 times 1/3. So therefore we have 1/6. Next, if the chances is in a box 2, so the probability is 1/2. But we have to anticipate which of this ball will be taken out. So in this case, so this is for the red, we have here 1/2 times the probability of, if the red is selected, here is 1/4. So therefore this is 1/8. And the probability when we choose blue is equal to 1/2 times 3/4. That is 3/8. Since the question here is find the probability of selecting a red ball, so therefore the probability of selecting a red ball is here and this part. So therefore we could say that the probability of selecting red balls in the two boxes is equal to 2/6 plus 1/8. Okay, plus 1/8. If we're going to have this one, we have 1/3 plus 1/8. So the LCD is 24. So 8 plus 3. So therefore, we have 11/24 is the probability when we select red in two boxes. Okay, so we have here tried this at home. So a box contains 3 defective and 4 non-defective transistors. One random selects a transistor without replacement until a non-defective one is obtained. What is the probability that the number of transistors selected is 3? Two bins contain transistors. The first has 4 defective and 15 non-defective, while the second has 3 defective and 22 non-defective. If the probability of picking either bin is the same, what is the probability of picking a defective transistor from the second bin? So thank you so much everyone for listening with this Kasaligan vlogs. We talk about multiplication and addition rule of probability. I hope everyone you listened. You have listened to the discussion, and I hope everyone you understood. If you have some questions, just clarify me in our class or just comment your clarifications here in the comment box. And I really appreciate for your kind and consideration for the errors that I might commit here. So thank you so much, and please do not forget to subscribe to the channel Kasaligan Max. Thank you, and comment your answer here. Thank you and God bless.